So today in class, we made the jump from one variable equations to two variable equations. And we really looked at how you can graph absolute value functions. We talked about the parent function for absolute value, and the parent function for absolute value is f of x or y equals the absolute value of x. That is the most basic absolute value function you can have. Some things we looked at on the graph is that the graph is V-shaped and symmetric, and its vertex, which is going to be your starting point, is at 0, 0. What we looked at in class today is how we can come up with new functions and new graphs based on changes to the equation. Today in class, we worked with the basic formula, y is equal to a times the absolute value of x minus h plus k. And you can actually graph any equation just by looking at this function. The first thing you're going to graph is the vertex, and that is your starting point. The vertex is found at h and k. K is pretty easy to write down, and this is going to be an order pair. H sometimes can be a little tricky. What you need to remember is this is x subtracting h. H is what is after the subtraction sign. It is not connected to the subtraction sign. So for example, if you have the expression, the absolute value of x minus 3, your h value is actually 3, because that is what is after the subtraction sign. However, if you have the expression x plus 3, this is when your h value is actually going to be negative 3. And the reason is this general form uses subtraction, and that's what it should use. If you ever notice that it is an addition problem, the reason that is because this originally was x minus negative 3, where h would have been negative 3. We just don't ever leave a double negative. We always change it to addition. So you do have to be fairly careful when it comes to writing down your h value. K, however, is exactly as it is written. Once you have your vertex plotted at the point hk, and again this will work just like an ordered pair xy, you're going to use your a value, which is your slope, to be able to graph the sides. So if you go to the next page, let's look at a couple examples. The first example at the top of the page is y is equal to the absolute value of x plus 4 minus 2. And one thing I suggested to the students in class is that they maybe write the general form over the top until they get used to where all of their parts are located. Okay? Let's first figure out where our vertex is going to be. So we need the value of h and we need the value of k. Looking at this, again, it's x plus 4. It's supposed to be subtraction, which means that h was originally a negative number. So my h value is negative 4. My k value is, as it's written, it's negative 2. That is where you're going to plot the vertex. For the graphs in class, I assumed that the very center was 0, 0. So from there, I'm going to move to the left 4 and down 2, and that is where my vertex is going to translate. From there, I now use my a value, which in this case is a 1, okay, as my slope. Normally when we do slope, we rise and run in one direction. Because we need to get that symmetry for the V-shaped graph, we are actually going to rise 1 and run 1 in both directions. It's very symmetric. And then you just draw on your sides. And there is your graph of this function. Another thing we talked about in class today is when the graph stretches and when it shrinks, and also when it reflects. The reflection is probably the easiest part. It will be a reflection, or the V will open down, when your A is a negative value, when you have a negative slope. That will cause a reflection of the graph. As far as stretching and shrinking, the graph will stretch or become narrower if your A value is greater than 1. It will become wider or shrink when a is less than 1. And again, they're not talking about negatives here. We're really referring more to fractional values like 1/2 or 1/5. That's when your graph will condense or shrink. So for example, if we look down here at this graph, we have y is equal to 1/2 times the absolute value of x. First of all, because we do not see an h and a k value as in the general form, we are assuming that our vertex is at 0, 0. And now when I look at my slope, which is 1/2, or up 1 and over 2, that allows me to draw in the sides. And you can see, because my a value is less than 1, this graph is much wider. Moving on to the next page, just another example. we look at this first example here. Again, establish and figure out where your vertex is going to be. And in this case, h and k will be at 1 and 3. So from the origin, I'm going to go right 1 and up 3. This function has a slope of, has a function of -2. You may want to think about that as -2/1 since we're working with slope, which tells you to go down 2 and over 1 in both directions. And there is your graph. So that is what we worked on in class today. Your assignment is attached on Blackboard. For Friday, it's called Graphing Absolute Value Equations Worksheet.